You have learnt that if a line L passes through the origin in three-dimensional space, making angles alpha, beta, and gamma with the positive directions of the x, y, and z axes respectively, then the angles alpha, beta, and gamma are called directional angles of the directed line L. The cosines of the directional angles of a directed line are called its directional cosines. Thus, cos alpha, cos beta, and cos gamma are the direction cosines of directed line L. By convention, the direction cosines cos alpha, cos beta, and cos gamma are denoted by the letters L, M, and N respectively. Note that a line can be extended in two directions in space. If we consider the opposite direction of line L, then the angles made by the line with the x, y, and z axes are supplementary angles to alpha, beta, and gamma respectively. In this case, the direction cosines of line L are minus cos alpha, minus cos beta, and minus cos gamma respectively. Hence we can say that every line in space has two sets of direction cosines. To find the direction cosines of a line that does not pass through the origin, we consider a line parallel to the given line and passing through the origin. Since the two lines are parallel, the angles made by them with the coordinate axes are equal. Therefore, the two parallel lines have the same direction cosines. Now, let us derive a relationship between the direction cosines of a directed line. Consider a line L in space. Draw a line L1 parallel to line L and passing through the origin. Consider a point P with the coordinates x, y, and z on line L1 such that its distance from origin O is r. This gives the relation x square plus y square plus z square is equal to r square. Let this be equation 1. Let PA, PB, and PC be the perpendiculars drawn from point P onto the x, y, and z axis respectively. Therefore, the lengths OA, OB, and OC are x, y, and z respectively. Let alpha, beta, and gamma be the angles made by line L1 with the positive directions of the x, y, and z axis respectively. Thus, the direction cosines of the given line are cos alpha, cos beta, and cos gamma. In right-angled triangle OAP, cos alpha is equal to OA upon OP, or x upon r. This gives us equation 2. Similarly, finding the value of cos beta from right-angled triangle OBP, we get equation 3. The value of cos gamma from right-angled triangle OCP gives us equation 4. Adding the squares of x, y, and z from equations 2, 3, and 4, and simplifying, we get equation 5. Substituting the value of r from equation 1 in equation 5, we find that the sum of the squares of the directional cosines of the given line L is 1. While deriving the relation between the direction cosines of a line, we arrived at 3 equations as shown. the expressions LR, MR, and NR represent a number triad that is proportional to the direction cosines L, M, and N of the given line. Any three numbers that are proportional to the direction cosines of a line are called the direction ratios of the line. By convention, the direction ratios of a line are represented by the letters A, B, and C. Since direction ratios are proportional to direction cosines for any non-zero real number lambda, we can express direction ratios in terms of direction cosines as shown. A line can have infinite sets of direction ratios corresponding to different values of lambda. Let us now derive a relation between direction cosines and direction ratios of a line. The ratio between the direction cosines of a line and its direction ratios is constant. Let this constant be k. Equating each term of the previous equation with the constant k, we get the three equations as shown. Squaring and adding the values of the direction cosines of the line from equations 1, 2, and 3, and simplifying, we get equation 4. We already know that the sum of the squares of the direction cosines of a line is equal to 1. Substituting this value in equation 4 and simplifying, we get the value of k as shown in equation 5. Substituting the value of k from equation 5 in equations 1, 2, and 3, we get the relation between the direction cosines in terms of the direction ratios of the line. The sign for the direction cosines is taken as positive or negative depending on the desired sign for the constant k. Now, we will derive a formula to find the direction cosines of a line passing through two given points. Consider a line passing through two given points A and B as shown here. Let us find the direction cosines of this line. Draw a line passing through the origin and parallel to the line passing through the given points A and B. Let alpha, beta, and gamma be the angles made by the line passing through the origin with the positive direction of the x, y, and z axes as shown. Thus, the direction cosines of the given line are cos alpha, cos beta, and cos gamma. Draw a perpendicular BQ from point B to the xy plane. Now, draw a perpendicular AC from point A to BQ. From the two similar triangles shown in the figure, we find that angle BAC is equal to angle beta. In right-angled triangle BAC, cos beta is equal to AC upon AB. Let this be equation 1. From the figure, AC is equal to y2 minus y1. Using the distance formula, we get the value of AB as shown. Substituting the values of AB and AC in equation 1, we get the value of cos beta as shown. Similarly, we can find the values of cos alpha and cos gamma. Using these equations, we can find the direction cosines of a line passing through given two points with the coordinates x1, y1, z1, and x2, y2, z2. We can also find the direction ratios of a line passing through two given points as shown here.